Good evening, ladies and gentlemen. Welcome to the Smithsonian American Art Museum. My name is Laurel Fehrenbach, and I work here in the Public Programs Department. I'm delighted you could all be here for this evening's lecture. Thank you so much for coming out on such a cold, rainy evening. This is the fourth of a six-part series, our Art and Science lecture series in conjunction with the exhibition Alexis Rockman, A Fable for Tomorrow, which is upstairs on the third floor and is going to be on view until May 8th. So if you haven't had a chance to see it, I highly encourage you to. A little housekeeping before I introduce our excellent speaker this evening. Could you please turn off your cell phones? The signal will interfere with the sound system, so if you could even turn it off, completely, no silence or vibrate or anything, because the sound waves will get kind of funky, so if you could just turn it completely off, that would be much appreciated. Before you leave tonight, if you want to pick up our new spring calendar, it's all the programs that we're doing at the American Art Museum through the end of May. And please consider filling out a comment card before you leave so that you can give us your feedback about our museum and programs. Let us know how we're doing. We are webcasting this talk, so if you would like to ask any questions at the end of the talk, if you could use the two side microphones in the aisles so that we can get the questions recorded and so that everybody in the audience can hear them. Finally, our next two speakers in this series are Rhonda Rollin-Shearer on Tuesday, April 19th, and Christian Samper, who's the director of the Natural History Museum here at the Smithsonian, will be speaking on Wednesday evening on April 27th. So please join us for our final two speakers. Tonight, however, we are delighted to have Stephen Monfort, the director of the Smithsonian Conservation Biology Institute. In January of 2010, Steve Monfort was appointed to the position of director of the newly created Smithsonian Conservation Biology Institute. The Institute oversees the Smithsonian's efforts to use science-based approaches to conserve species and train future generations of conservationists around the world. Since 1986, he has served the Smithsonian in many roles, including veterinarian, research scientist, educator, and conservationist. And in 2006, he became the zoo's associate director for conservation and science. As a scientist, Monfort helped to pioneer non-invasive endocrine monitoring techniques that are now widely used for assessing reproductive status and well-being of wildlife species in zoos and in nature, as well as launched a number of important conservation initiatives for amphibians in Panama, tigers, wild horses, and many more species. He has collaboratively worked with the George Mason University to establish the Smithsonian Mason Semester in Conservation Studies, a program that immerses undergraduate students in an interdisciplinary conservation learning environment at the Smithsonian. Monfort received his BA in biology from the University of California, San Diego, his Doctor of Veterinary Medicine and master's degree from the University of California, Davis, and doctorate in environmental biology and public policy from George Mason University. Please help me welcome Dr. Steve Monfort to the podium. Thank you.
Thank you. Thank you all for coming. It's a pleasure to be here. It was a challenge when I was invited because I thought, I'm not really an artist, right? So I could never, I always think back on what it was like to, as a child, and I realized I really couldn't build anything. I couldn't draw, I couldn't paint, I couldn't do anything like that. And when I got older and I started to go to college, I realized that there was something that I saw in scientists that was inspired me, because the scientist creates something from knowledge and through their work, and then they publish a paper and they get to put their name on that. And in a way, that is their legacy, or maybe it's their way of expressing their creativity. And so I thought it was an interesting challenge, the idea of talking about the art and science of conservation biology. And so you probably don't even know what conservation biology is, many of you. So I want to start there. What is this name that we have, the Smithsonian Conservation Biology Institute? It's really about scientific discovery as the base of what we do, and that's the Smithsonian is a knowledge sharing and an increase in diffusion of knowledge is our mission. We're consistent with that. Science and discovery is at the base of everything that we do. The difference is that we're not just about understanding and studying biodiversity, for example, we're about conserving biodiversity. So we take the science that we do and we apply it to solving problems that will help to conserve biodiversity. We also recognize that it's important for us to sustain the efforts that we do into the future by training the next generation. And through the zoo and the animals that we display there and the work that we do around the world, we hope that we're actually inspiring people to take action to do something to help conserve the environment. It's an applied discipline in that it's not just about biology, it's about public policy, it's about law, it's about economics, it's about anything and everything that needs to be brought together to solve a conservation problem. That's the name of that discipline. If you ask scientists at the Smithsonian to self-identify what they are, very few will say, I'm a conservation biologist. Most of them would say, I'm an entomologist, I'm a tropical ecologist, I'm a marine and estuarine biologist, whatever. And I started as a research veterinarian, a wildlife veterinarian, I'm as an endocrinologist, a physiologist, a reproductive biologist, and eventually I decided that I had evolved into a conservation biologist. We work mainly on species-based programs. They're kind of our icon, they're our reason, they're our inspiration for working. We're a species-based conservation science organization, but we do much more than just focus on the species. We have a headquarters out in Front Royal, Virginia. It's a 3,200-acre facility. But SCBI, as our acronym goes, is not just about a facility. It's about everywhere that we work. We have labs down at the zoo. We have a coral lab in Hawaii. We have programs in Peru, in Gabon, and around the world. So when we talk about SCBI, we're talking about the work that we do in 25 different countries around the world today. I already mentioned sort of the focus of things that we do, and I'll move on. We started off, first of all, I started my career as a zoo biologist, as an intern in 1979 as an undergraduate, and then also as an intern at the National Zoo in 1985 as a veterinary student. Zoos have evolved over time. They started out in sort of the 1800s as menageries, basically, as places of entertainment and displaying animals in like a living museum, if you will. And then they became this continuum of this menagerie up to a living museum, where maybe ecology became the focus of, well, people wanted to understand life history of animals and their basic science and their biology. And that was important. But now we're sort of at this tip of the spear, which is, what about the conservation of species? So I want to talk a little bit about that through my talk. And I'm going to start off by, though, these are some of the themes and the concepts. I went back and I listened to the talk that Alexis Rockman gave and some of the things that he spoke about when he was here. And these are some of the things that I picked up from what he had to say. He's interested in the global environmental problems. He talks about climate change and extinction, the resilience of animals and how they persist in the face of this degradation. And also, I think, rather than being a pessimist, I think he's actually trying to open our eyes to what the issues and the problems are. And while he says he's not really an activist or he's not trying to make people feel bad, I would like to say there's some optimism in what he's doing. He's trying to inspire us into action. I think that's a similarity with conservation. He says that basically extinction is inherently political. I would agree with that. Conservation biology, while we are not a policy organization and we're not allowed to basically be advocates per se, the truth is everything we do is meaningless unless it can influence policy and change the way we do business in the world, things that impact the environment and nature. And this idea of this unflinching gaze at the hidden truths that we fail to see, those things that are under the surface, things are not always what they appear to be. And I mentioned this optimism. I think that's something I got out of the talk and his art. And so what can we do to impact, make a difference? So I'm going to try to give examples of things that kind of touch on these themes. And I'm going to talk about maybe what are the problems, how they come about, what is some of the science that we do in order to address those things, and what are some of the things that we try to do to actually correct and to solve the problems that exist. Many of you probably are familiar with Aldo Leopold, a famous conservationist, and here he says, our ability to perceive the quality in nature begins, as in art, with the pretty. It expands through successive stages of the beautiful to values as yet uncaptured by language. And I think that most of us realize the nature, biodiversity, what does that mean? To many of us, it has to do, there's an aesthetic value to that. Beyond that, there are values to our survival that I'll talk about. Now, this is to be this sense of wonder. I think I also want to have a sense of humor. And this is a colleague of mine standing next to a piece of art. But I thought to myself, what is it that scientists and artists have in common? So these are just a few of the things. And Alexis, he referred to some of these things. We have a sense of wonder. And, I tend to supervise scientists now, so, and they're not here, so I can say this. But narcissistic tendencies are definitely a problem. That's common for all of us. Prima donnas, I like to call my guys prima donnas. They don't like to be managed. They're very creative. Just stay out of their way and let them be brilliant. The idea of travel and adventure, there's a certain youthful enthusiasm that I see even in, I have scientists who work for me that look, they're 55, 60 years old and they still dress like a postdoc. It's just wonderful. This youthful enthusiasm. This idea of our awareness of one's mortality and what is our legacy. I think that fits into the narcissism. But the idea, you have scientists who gauge their success by how many publications will they publish in their career as first author, second author, multiple author in high impact journals or whatever. And just like an artist, I think, they count things. And where the things are displayed counts to them too. So this idea, scientists love to make you feel uncomfortable because they want to challenge dogma. They want to be able to say, I'm tilting against a windmill here. I'm going to challenge that idea. This idea of searching for that hidden truth that lies beneath the surface, that's inherent in exploration and discovery, which I think is something that scientists and artists share. And this idea of taking something that Alexis talked about, this idea of perfection and shining a light on it to really see whether it's perfect or not. Okay, so here's another quote. Rachel Carson, those who contemplate the beauty of the earth find resources of strength that will endure as long as life lasts. Rachel Carson was a pioneer that led to a revolution in our country, an awakening and awareness of the environmental problems and issues that we were facing. But I guess I would say, what would she think? What would she think today? The state of the environment, the state of the globe. We're currently at 125% of our sustainable productivity already on the planet. It would take 2.5 planet Earths for everyone on Earth to live at the same level of a standard of living that we currently live now. The United States alone, here we have 4.5% of the population and we use 25% of the resources. So where is that leading us to? So this idea of biodiversity, I mean, what is biodiversity? And I think it's a jargon name. Many people, biodiversity the term didn't even come to be until in the 80s. Tom Lovejoy, actually biological diversity, when it morphed into biodiversity, the word conservation biology came out in the mid-80s. The first textbook came out in 1988. So this is a new thing, but what the heck is it? I would say the general public doesn't understand what it is. Well, what it is, it's the health of the planet. It's pretty straightforward in that way. Everything biodiversity offers us is essential to our lives. The air that we breathe, the food that we eat, the water that we drink, the aesthetic qualities of the globe, the fascination with nature, that's all biodiversity, every bit of it. And it has economic value that's measured in the trillions of dollars a year. So there have been calculations in the trillions of dollars. That's lost ecosystem services. And what are those things? Those are, I already mentioned them, the clean air, clean water, and food. But it's things like coral reefs that buffer tsunamis, and it's things that flooding that is prevented by having healthy forest. It's basically a buffer to humankind that was there and that's being eroded. And as it erodes, we become in greater risk. I want to talk about climate change. This is something that just absolutely drives me crazy. And it wasn't until climate change is real. I absolutely know it's real. The scientific data exists to say it's real. But it didn't come into the public's awareness, I don't think, until Al Gore did his Inconvenient Truth. And all of a sudden, climate change became part of everybody's jargon. It became part of every grant that you had to apply for federal funding. If it didn't have climate change in it, it wouldn't be part of any kind of government initiative that was going forward. And this is a problem because, you know, we were doing a lot of bad things before the word climate change ever came about, and plenty of things that were going to destroy biodiversity before climate change took effect. And so, what are those things? Well, you know, overexploitation of resources, invasive species of plants and animals that now, you know, the world is flat, and so these things go everywhere all at once. You know, ships are bringing ballast water through ports. It's just, you know, we share the same air and so forth. This idea of habitat fragmentation and habitat loss and pollution. Those were the, and now you add in the climate change, and in my view, the other things are actually more urgent with respect to biodiversity loss than climate change. So climate change is coming, but you and I are going to be long gone before climate change really has its most drastic impacts. So I would prefer that we say what we used to say, which was global change. You know, the world is changing, and it's changing because of us. And the climate is definitely changing. But there are things we can do now that we can stop global change from accelerating and biodiversity loss from accelerating. The climate change is going to take more drastic measures and going to take longer time frames and more amounts of money. And the truth is that it gives you this sense that there's still time, that there's this, you know, we have time to solve the problem, but the reality of, you know, it's going to be really left probably to many, many generations of time before we come to equilibrium with climate change. So why is that a problem? Well, these are the taxonomic groups of species that exist, and the ones that you're aware of, mammals and birds and so on. And the red is indicating for you all these are all critically endangered species. The percentage of all these species that are currently at high risk, either threatened or endangered for extinction right now today. And those are based on things that have very little to do with climate change. So we're causing the extinctions of thousands of species, 100 to 1,000-fold background extinction rates, and these things are causing major infrastructure development projects, extractive industries, if you're getting oil and gas, land conversion for agriculture, illegal killing, trade, and trafficking, and the truth is that many, many species are worth more dead than they are alive. So it comes down to, well, how do we value things? How will we change the paradigm? How do we make things worth more alive than dead? So I want to talk about the one thing I'm really pleased with is the Smithsonian redid their strategic plan last year. And when they did that, prior to this time, they talked about studying and understanding biodiversity. So what does that mean? I feel that means really for most scientists, I said they don't self-identify as a conservation biologist. It means that they would go to Jamaica and classify all the flies of Jamaica, or they would go to the tropical forest and fog a tree in the canopy and then collect all the bugs, and they would count them, and this would document biodiversity. But they weren't doing anything to actually try to save any of that biodiversity. And the National Zoo and the Smithsonian, you know, finally was able to get this word sustaining in there. Now, they didn't go so far as to say conserving, because that's too political. You know, they were afraid some congressman or someone would get upset if we were being too risky. We don't even get to use climate change in our language at Smithsonian. We have to now, as our money's being taken away, so we're starting to go back to saying global change. So anyway, I just want to say we now have it as one of the four pillars, one of the four grand challenges under the increase in diffusion of knowledge. We now have four grand challenges. One of them is understanding and sustaining a biodiverse planet. So that's a big breakthrough, and it's a boon for us. So what are we all about? We're about saving species that are on the brink. You know, we're the SWAT team that gets called in when you're down to your last fragments of populations, and there's little known about a species, and they want us to save them. That's really what it comes down to. The problem is it's not the time to do science when you're down to your last 20 animals. You should be doing the science when you have thousands of animals left. And these are all species that we basically played a major role in bringing back from extinction or reintroducing into the wild. And I'm going to tell a few of those stories. I'm going to start off by talking about amphibians, because I think Alexis Rockman likes frogs, and he alluded to the fact that they were in trouble. And so why are they in trouble? Well, you've maybe heard of this enigmatic decline of amphibians. Species are going extinct, and nobody really knew why. Was it UV radiation? Was it pollution? Was it toxins? What was it? It turns out that in somewhere in Australia and back in the 40s and 50s, they did pregnancy testing. And the way you did pregnancy testing at that time is you collected urine from a woman who might be pregnant. You injected it into the abdomen of a frog, Xenopus laevis, or into the abdomen of a rabbit. And then a couple days later, you would then slaughter that animal and you would look at their ovaries. And if their ovaries were stimulated, then that was a positive pregnancy test. But once you no longer needed to do those tests, you didn't need those animals. And so somebody thought it would be kind act to release some of these frogs into nature. It turns out that this particular species of frogs has a fungus on its skin. And that fungus doesn't do any damage to that species, but it persists in the environment. And there are most species of frogs and amphibians that come into contact with that fungus, it causes ulcerations, and it damages the ability to trade your mineral balance across the membranes. Frogs breathe through their skin, and they die, and it causes more than half the species that come into contact with this fungus go extinct. Up to 80% of each species that is impacted of the individuals will die. So it actually is moving. This is all the places in the world where it's been documented. We note we've been tracking it in Central America, and you can see over the timeline it's moving down towards Panama. It's also doing likewise, it's moving up. And there's this one area of Panama that we believe is the last place that we know of where this fungus, that's a high elevation fungus, does not exist. And so what we're doing as a matter of desperation is we're going in and we're collecting species of frogs. We're bringing them into captivity. And these are species of frogs that have gone extinct. And people say, well, why should I care about frogs? All of these frogs had some potential benefit to humans. They're part of the food chain. They're part of that web of life, knocking down mosquito populations. Well, so we recognize that if we don't go in and do something, then they certainly are going to go extinct. And so our strategy has been to rescue species of frogs. Before that happens, we're trying to develop simultaneously a cure for the fungal infection and a way to inoculate the frogs so they can be reintroduced back into the wild into the future. And so this is, we have set up a program. It's a partnership with STRI, the Tropical Research Institute, and a number of other defenders of wildlife and a few other zoological organizations. And we're using these shipping containers, and we outfit them with electricity and air conditioning. And these are set up, and we have these rescue terrariums. We do expeditions into the field. We bring them in, and we set up breeding programs. And so going back to the cure function, what we're finding out is that probiotic bacteria that are found on some species of salamanders and some species of frogs provide a protective coating on the skin, and that we are doing challenge testing where we're actually inoculating the frogs with this bacteria, and we're challenging them with a fungus and seeing if they live or they die. And so we're trying to come up with a strain of probiotic bacteria that can help to inoculate frogs that could be reintroduced. That's an example of one of the things that we're doing. This idea of biodiversity, again, we don't know how much biodiversity there is still. There's about 1.5 million species described. There's probably something like 10 million species once it's all been done. Molecular techniques are broadening our horizons. But you first have to know what's there in order to know whether it's going away. And that's important work for a biodiversity scientist to do. The Smithsonian has tremendous capacity in this area, taxonomy and systematics. The Natural History Museum is well known and respected for that. And so it is important. But the thing is, it's not just important, in our case, to just go count it. We're trying to use it as a tool for determining whether or not extractive industries are actually damaging biodiversity. So what we do, rather than just avoid working with industries that extract oil and gas from the ground, our feeling is they shouldn't operate in a black box. If we can conduct science that can document whether the practices that they're utilizing are damaging and they're willing to change those practices based on scientific evidence, then we're going to be there. And that's what we're doing with oil companies. and working to monitor the biodiversity that's there, try to document which practices are least impactful on biodiversity loss, trying to ultimately improve the conservation of species. So we're working in a variety of different countries. I'll give you this one. Our main programs are in the Peruvian Andes Biodiversity Program. We also work in Gabon, and they're putting in a natural gas pipeline. So the question is the construction and operation of this pipeline damaging to biodiversity? Obviously, the tract of area that they're working with, does it have impacts on species that live around it? What are the species that live around it? And what happens to their life history patterns? Are they disrupted? So we set up the scientific protocols to allow that to be tested. Here is working with Repsol. This is an area that we work in, block number 39, and so it's near the Ecuadorian border. And what we do is we set up these systematic grids, and we use camera trapping to study. This is Joe Klowski, one of our scientists. We use camera trapping to look at patterns of movement when they're doing seismic exploration activities. And as a result of that, we can actually quantify movement patterns. So here we're documenting through camera trap surveys and radio tracking. We put radio collars on animals that we track and follow their movement patterns to determine whether or not it's causing a change in their behavior or a change in their abundance using the camera trapping, density estimates, and so on. And so far in the case of the ocelot, that was an example, the one target species, and we did not show an effect. But these are all the other species that would, some of the other species that would be there that you would not see typically, but using methods like camera trapping and using systematic survey methods, you can actually quantify how many are there, and ultimately we hope get information about what the impacts of the practices are. I would encourage you to go to this website that just got posted. Camera trapping is something that allows you to really see species that you would not see typically during at any time just walking around. Many species are nocturnal, they live in forests, they're difficult to see. But camera trapping, this new website, one of my staff was really the person who led this. He'd done a study along the Appalachian Trail and had volunteers setting up cameras across the entire trail and monitored got thousands of pictures of different species of what's actually there. So this is all just came up a couple of weeks ago. There's 200,000 images or camera trap images from all over the world on this site now that are freely available to anyone. So a pretty cool thing. Another way that we do biodiversity monitoring is in the United States. We have a continental scale program that has to do with, it's called the National Ecological Observatory Network. And what that is they've carved up the United States into 20 ecological domains, and they're going to put out instrumentation that will measure the air quality and basically looking at carbon in the atmosphere above the tree canopy and how much is being sequestered by the forest, looking at things like water quality, soil quality, and so forth. These will all be collected simultaneously at 20 core sites and regional areas around the United States. And SCBI is one of the core sites, one of those 20 core sites, meaning that our domain spans from Georgia all the way to Pennsylvania. And so these are the kinds of data that need to be collected over many decades of time. So when we talk about climate change, we talk about global change. Currently, we don't have data sets to actually look at those things. Everything's based on modeling. So this is an attempt to actually create real data that 100 years from now or 200 years from now, you can actually start to make actual predictive models. You can look at what has actually happened in the forest. We also work with this program, SIGEO, which is the Smithsonian Institution Global Earth Observatory Program. That one was started in the tropics at Stry, and that involves basically looking at taking a 50-hectare plot, which is about 100 acres, and going in there and surveying the plot and measuring every stem of every woody stem greater than 1 centimeter in diameter, which takes usually more than a year, but takes usually 2 years to set up the plot and to do the first measurement. Every 5 years you go in and you measure it again, you put it on a grid, you map it through coordinates, and you look at the diversity or the dynamics of forest change over time. Very powerful technique, takes a long time, a lot of patience to do it. This is a schematic of this NEON model, and again showing how we're going to use it. And eventually, this kind of a network of monitoring sites will probably be implemented like our SIGEO program, but using similar instrumentation around the world. What we're doing in our system is we're at the headwaters of the Chesapeake out in the Shenandoahs, and we're collaborating. Our gradient goes all the way out to CERC, Environmental Research Center, and we're looking at basically the gradient, the headwaters to the bay, kind of gradient in terms of water quality issues, and also looking at the impacts of urbanization, the gradient of basically going from a wild to a rural and urban gradient on the effects on biodiversity. So this just showed that we were in a forest plot here in Gabon last year, and this was getting set up. It's taken a year and a half to do. We're setting that up there. And we also work with the forest industry, because there are now honest attempts being made to do sustainable harvest of wood products. And these guys have some of the best data of anybody on Earth, because what they do is they map out, they invest millions of dollars in mapping out their forest tracts, and they plot out for the next 30 years how they're going to go through and take different trees out, because they're only interested in trees of certain species and size and so on. So we can actually design experiments that say, what happens, what's the biodiversity there before? What is the impact of your practices in terms of things like runoff or destruction of habitat and so on? And then what happens when you plant new trees there and they grow over time? What happens to the environment then? So these are long-term ecological experiments that we're doing. Another thing we're recently doing is we're out in Front Row. We have 3,200 acres. We're one of the largest land owners in the region. And we're learning that there are people who, from DC, let's say, they go out, they buy a place in Rappahannock, they've got 50 or 100 or 200 acres, and they get a conservation easement. They get a tax write-off. And then they think, I've got it made, and they're not really farmers, and they're not doing anything with their pastures, and pretty soon they've got autumn olive and invasive species coming in, and then they're in trouble because their land has not been managed. And so sitting there, leaving land alone is not the same thing as managing the land successfully. So in the case of pasture land, it needs to be taken care of, and there's now a movement towards planting warm season grasses instead of the fescues that we're so used to here. The native grasses, they have larger root balls, they sequester more carbon, they promote more biodiversity above, and they attract bird species like bobolinks and other native wildlife species. So we're working now, we're a focal point for landowners that want to work with us, because we have the same problems they do. We have invasive species. We've done poor land management practices until the recent years. And so we're working together, forming a network and a partnership with other organizations like the Piedmont Environmental Council and the Shenandoah National Park Trust, for example. We talk about, we always think about endangered species, and that's what we deal with the most. But here's an example where we're talking about an overabundant species. White-tailed deer, 25 million white-tailed deer in North America. Half of all the deer species on the planet, I'm a surveyed guy, half of all the deer species on the planet are threatened or endangered with extinction, but everybody here thinks of them as being, rodents with antlers. And, they're pests now. And Rock Creek Park has something like 25 to 28 deer per hectare. We have about 15. They should have about about 8 or so would be a normal number. So you're talking about massive numbers. So when you look at Shenandoah National Park and you think, let's go out to Skyline Drive, it's beautiful out there. And it is beautiful out there. But did you know 100 years ago, that was all farmland? And all of that is secondary forest growth. And all those deer weren't there then, and now they've moved in. And guess what? The forest is dying. It's a dead forest, essentially, because all of the seedlings that are growing up are being eaten before they ever grow to be a size that can't be destroyed. And what that's going to lead to is a dynamic change in the forest. So oak species will be dying out, other species will be moving in, and 100 years from now you're going to have a different kind of forest unless something's done. This is the kind of science we've been doing for 25 years. We've been doing exclosures where we keep deer out, and then we have other areas where we document the deer density, and we can look at the biodiversity, we can look at the tree growth rates, the amount of carbon that can be sequestered. All that's being done because teams of scientists out there thought about this. They didn't even think about climate change 25 years ago, but they were thinking about white-tailed deer then. And now it's turned out to be this incredible long-term data set of great value. here's an example of a high-tech kind of approach to conservation. Black-footed ferrets of the American West. They actually were down to the last 18 individuals in the wild, and they were declared extinct. And this farmer, rancher, out in Meeteetse, Wyoming, his dog came home with an animal in its mouth he'd killed, and he recognized it as being something unusual and called this extension agent, who came out and identified it as a black-footed ferret. They went out and they rescued this last population of 18 individuals, brought them into captivity, and all living animals now are descended from those 18 founders. And of course, not all of them bred, and so the actual founder lineage from the day zero is much less than 18. But we were the first place outside of Wyoming where they sent these animals, because they realized that, you know, it's not like you can create a stud book and you can say, here's all the founders. Like, pretend you landed on a desert island and you were going to start a new civilization, and everybody in this room, you were all the founders. Now, if each of you didn't reproduce and pass your genes on to the next generation in equal distribution, over time you would start to get inbreeding and you would start to get genetic drift. And so the idea of managing a species for genetic diversity means everybody's equal. It doesn't matter how pretty you are, how strong you are, anything, but your genes are important. And so you want everyone to breed. Well, as you might imagine, you know, somebody over here might not like somebody over there, and you're not going to breed. And so there have to be ways around problems, and even when there are health problems. So we learned how to get around that through artificial insemination. And since that time, we've produced, you know, several hundred offspring using males that would not otherwise reproduce, and have these are animals that have been reintroduced into the wild. There's over 800 now actually in the wild in 7 different states that have been reintroduced, all in the span of about 25 years, which is pretty incredible if you think about it. One of the more fantastical things that occurred is that in the process of developing artificial insemination, we learned how to freeze the sperm in cryostorage, which would mean it can live there forever. And so in 2008 and 2009, we thawed out sperm from animals that had been dead for all those years. So 10 years. In the case of 20 years, that would be equivalent to a lifespan of a ferret. If you translated that, they only lived to be about 4 years. You translated that into human years, it goes back many, many generations, back to almost colonial times. So it's a pretty impressive undertaking. I want to talk about migratory birds. We house the Smithsonian Migratory Bird Center within our institute, and this is another species of great importance to those of us who love art, who love beauty, who love wildlife. And what we do is we study the migration of birds that move great distances, thousands of miles, to come up here, right, arriving now, that we're overwintering in places in Latin America and South America, and amazing journeys. These birds will fly for sometimes days at a time over, at great peril to come here. But they also are potential disease vectors for pandemics like West Nile virus and avian influenza, and also with climate change and other kinds of patterns, their migratory patterns will change over time. And so we're studying that. And just today, we put out a press release about an article that's coming out that's showing that it looks like rain patterns in Latin America may rain, when rain falls, you get insect growth and flushing, which causes the food to be more abundant. As the rainfall patterns are declining or shifting where it's becoming drier, birds are being forced to migrate earlier than they would otherwise do so. And we always thought before it had to do with light cycles and so on. Now we're learning that climate change may have actually impacts that we hadn't foreseen. The idea we can monitor these birds over these vast distances now, so we can study diseases. This was Pete Mera, one of our scientists, but this just shows that something like West Nile virus, how radically it affected bird species compared to mammals and other species. But these kinds of monitoring devices now that we can place, these geolocators, that if birds are banded and can be recaptured in mist nets on their home territory, there's a lot of fidelity, site fidelity to breeding grounds. So birds will come back to the same place every year. If you place these geolocators on them, and then you can recapture them. You can basically download the data. It measures the sunrise and sunset, and from that you can translate their latitude and longitude and map out their migratory routes. And this is being used now. We're finding out incredible findings of birds who migrate as, frigate birds and so on that fly up to 10,000 miles at one stretch without ever landing, for example. So incredible phenomenon. We're also, the applied thing is, there's a relationship between habitats in Latin America and here, and this is something that people just didn't even think about. Why was it that the birds that were resident in Rock Creek Park were doing fine in terms of their numbers, but migrant species were declining? Well, because they were subjected to different pressures, and our group got into looking at agroforestry practices, especially with coffee production. And so there's shade-grown coffee is an alternative to sun-grown coffee. If you leave a certain density of trees in a plantation area where coffee is being grown, the amount of bird diversity stays the same. You cut down all the trees, you might produce more coffee yield, but you basically erase the biodiversity that's there. So one of the ideas is that we originated the concept of shade-grown coffee and basically bird-friendly coffee. You can find it online, not as widely as we would like, but it is available, and it provides a fair price to farmers who go through a certification process. So this is an example of applied, trying to find a solution to a problem, but it was the science that led us to understanding what the problem was, and then this became more basically a policy kind of and direct action to solve a problem. Talk about Asian elephants. And you think of elephants. Well, elephants, we know everything about elephants. I've seen them on Nature Channel. Every time I turn it on, I see these famous scientists in Serengeti and Masai Mara and so on. There's there's about 150 to 170,000. There's about 500 to 700,000 African elephants in Africa. There's about 30,000 Asian elephants. So the Asian elephants are under huge threats of extinction because of the population growth and changes that are occurring there. And so this is, in historic times, the distribution in the brown of Asian elephants. This shows back in 1900, we had the distributions were still pretty healthy here through these 13 range countries. And here we have in the 1980s and earlier. And you can see that, why is it like this? Well, it's because of human population growth, forest loss, and fragmentation. These guys need dry deciduous forest, and dry deciduous forests are often cleared for agriculture. And so this is one of the big problems. But there's a very interesting case with Asian elephants because they're so important culturally and in terms of, in religious ceremonies and in terms of cultural significance, they're revered animals. And so there's a high tolerance of having these animals there, and yet there's this inherent conflict between the needs of people and the needs of elephants. I could overlay tigers on this too. We're part of this global tiger initiative, but I don't have time. But it's the same kind of issues and problems that exist. So here you have also the connection to art. Well, isn't it awful? This is something of beauty, and it took great artistry to do that, but it also ended up, taking ivory from a living animal. And it turns out that the United States is the greatest importer of ivory. It isn't some other country that's doing it, it's our country that's doing it. So these are just facts that we have to deal with. The other thing I mentioned is, there's tolerance for the animals, they're revered, but when you have more people and you have more elephants, you have human-elephant conflict. So people's property gets damaged. This is from elephant damage. And this is our case in Sri Lanka. We do a lot of work in Sri Lanka showing the numbers of human deaths in Sri Lanka related to elephant conflict. I can assure you that the number of elephants that are dying are much higher than that. But here, even when an elephant is killed, you can see that there's this reverence, there's this cultural sense of honoring the animal that's dead. Now, how that creates this interesting scenario if you think about it. If we, how many people have been killed by cougars in the United States? 18 since 1890. And here you have 120 or more people a year in one little country, and we wouldn't tolerate one person being killed. We'd be out. We'd take out and shoot it. We want to kill it. Ranchers don't want wolves. People want to get rid of grizzly bears. So our tolerance for this kind of human-animal conflict is much reduced compared to some of these countries in Asia. You would think that they would already have done something more drastic. So what are the causes of it? Well, this is a part of what we need to do as well. So we do the science, we understand the ecology. So what I meant to say is we do know a lot about an African elephant. Why? Because you can see them, you can habituate them, you can follow them every day of their lives, you can collect samples from them, you can do all kinds of stuff. But an Asian elephant, I can promise you, you can be from here to the third row, in the forest in Asia, and you won't see it sometimes. And so you can't study them if you can't see them. You can't study their social behavior, looking at how far do they walk. Well, an African elephant, we get this all the time from animal rights people. Well, African elephants can walk, they need to walk many miles a day. Well, Asian elephants will walk as far as they need to walk to get the food they need and the water they need. And if it's all there, they might walk 3 or 4 kilometers a day, not 50 like you might in African elephants. So their biology is different. So we do know a lot about their science and their life history. We're learning more all the time. But what's the cause of the problem that they're in? Well, it's this, one of the biggest problems is land conversion. And so here you have palm oil. So what the heck is palm oil? Well, this is, if you go to, I just came back from Kuala Lumpur. I'm jet lagged as heck. I got back Saturday night at midnight from an 8-day trip through Singapore, Malaysia, and Thailand. And you fly into Kuala Lumpur and you just see vast, hundreds of thousands of hectares of these palm trees being planted. This is what it would look like from a satellite image. And so what is this stuff? Well, it's in all these things that you're eating. It's everywhere. And it's basically, and the truth of the matter is, there are substitutes for this stuff, but it's become an industrial product, and we don't even usually know it's in our foods, or we're not aware of it. But this is directly causing the death of orangutans in Borneo and Sumatra, and elephants and other things because of our market for this product. Much in the same way that ivory is a product, so is those products. So what do we do? So SCBI and the National Zoo, we are the world's leaders in trying to study and protect Asian elephants. We have collaborators in Burma, in Sri Lanka, in Thailand, in Malaysia, and we're working where there are still plenty of elephants in the wild, and we're trying to understand how do we improve the well-being of animals in captivity. People say, well, some people will say animals should be dead rather than be in a zoo. Well, there are 30,000 wild elephants, Asian elephants in Asia. There's 15,000 captive elephants in Asia. All right, these are in timber camps, they're in orphanages, they're in tourist industry. So to say that somehow, let's let them go back to the wild is just incredibly naive. The wild doesn't exist for most of these guys anymore. And so that is not a solution. So in some cases, having animals in captivity for cultural reasons or religious reasons, or they've been honored for thousands of years in that way, we can do things that actually could improve their well-being and their health and so on. So we kind of crossed the entire gamut, everything from animals that are needing care by humans and those that are in the wild. Here's a case of Sri Lanka, which I wanted to mention. Look at this. I mean, this is the size of Sri Lanka, and here's, this pointer doesn't work very well. Over here is West Virginia, roughly the same size. You got 10 times as many people, and in that little space with 4,000 elephants. And so it's incredible that there isn't more. We use satellite telemetry. This is a satellite collar. So what is a satellite collar? It's literally sending signals to a satellite, and we can remotely collect the data. This is Homie. Homie was an elephant that went into garbage dumps, and he got into conflict with people. This is a satellite. We put satellite collars on some elephants because this is agricultural land. These are forest patches, and we wanted to know, how are the elephants how are they interacting in an agricultural setting? So here we are at noon during the day. Where are the elephants? They're hiding in the forest. During the afternoon, they come out of the forest. So if you play that back, basically here they are in the morning, they're coming out, and then they go back, they stay out at night, midnight, and then they come back in at 4 a.m., they're back in again. Elephants are damn smart. And so they get what they need when nobody's around, but we would never have understood that relationship had we not had the ability to do that. So here's poor Homie. He got collared, and the Sri Lankans for many years thought, well, the solution was you dart them and you run them up to the north and you let them go in a park, and that'll be good. Well, we put collars on Homie, and Homie went up here, and then Homie came back and broke through that fence that was there, an electric fence, and so they recaptured him and they sent him up here, and then he went around. There was a reservoir. He went all the way around, figured out a way to get through the reservoir, and then came back down here, and then he ended up getting in conflict, and he killed somebody, and then he got killed. So this was because we had satellite. This is basic knowledge that you need to know whether policies that you're implementing are effective or not. It feels real good to take an animal and put it up in the park. And this is a common thing that we do. We often translocate animals here too. Problem animals get moved. So this is another example about coral. So we study coral, and this is the world is mostly covered by water. Many people just don't even understand that coral are animals. People think that they're rocks or something, and so they're living animals. They reproduce by either sexual or asexual means. So here's an egg bundle that's magnified. And so why do we care about coral reefs? They're only 0.2% of the Earth's surface, and they provide about 25% of all marine life depend on them. That's a pretty phenomenal thing. They're like this breeding ground. They're this nursery for biodiversity in the ocean. They're just like trees. They're just like the Amazon in terms of their ability to sequester carbon. They're of great benefit to purifying our air. They help us from floods and tsunamis and things like that. And they're basically the sources of different medicines and things that we might benefit from as people. So here's a reef in the Bahamas in 1991. Mary Hagedorn is our lead scientist on this. And here we are in 2004. So it's a dead reef, basically. So one of the things that we're, drastic measures, what can we do? We don't really know what's going to happen. The trends are that coral reefs are going downhill. We have a lab, and this is the same place where they filmed Gilligan's Island many years ago. It's now been turned into a lab facility with the University of Hawaii, and Mary has a coral lab there. These are coral reefs surrounding her little island. And Mary basically has figured out how to freeze coral sperm. And so what they do is they can take sperm that's been collected, and they can then, during the spawn, they can move the sperm and create these, they can fertilize eggs. When you start to have coral reefs that are dying, it's just like forest fragmentation. Now, if you get a spawn and eggs are released, but there's no sperm anywhere nearby, you're not going to get any offspring reproduced. So what they do is you can actually take the sperm and you can move it to a place and you can help the spawn to grow more coral. So it's a high-tech approach, but we have to have these kinds of tools. You can propagate coral using this asexual reproduction. You can some species you just cut off a piece and you stick it in just like a plant. You might at your house with cuttings, or you collect the sperm and you do this in vitro. And so one of our biggest efforts is working in the Caribbean on these two species of coral, and working to understand the biology, but also trying to figure out how we can help process of the fertilization during the spawning. So I'm moving on to talk about the next generation. So we think of things in short terms. People are really good at looking at crises or short-term things, but we're really lousy about projecting future because we think about our own mortality, as I mentioned. So we think in things of 30-year careers and what we're going to achieve and how famous we're going to be. But the problems that I've been mentioning to you, those are problems that will be here now forever. And that's a hard concept, that the Earth will now be managed forever. So when we talk about trying to manage black-footed ferrets, and we've done something for 20 years, and we think, congratulations, you've done it. You've put them back into the wild. Well, our own government is trying to kill prairie dogs at the same time we're trying to reintroduce black-footed ferrets. This is going to go on for hundreds of years, thousands of years, 10,000s of years. So it's a mind-boggling. So what's the hope? Where's the optimism in that? I think anybody who is a parent, or anybody who's trained anybody and has great hopes for their future, I think that's what we hope for. We hope that the next generation can at least carry on and do as well as we did, or better, hopefully, than we did. And so we really are working on that. So this thing is, the problem is that the issues of when I first started in 1979, biodiversity wasn't a term. Conservation biology wasn't a term. I couldn't get a degree doing any of those things. I had to become one later. And here, the top 10 jobs that are sought after in 2010 didn't exist in 2004. So what we're doing is we're taking this current generation, we're trying to prepare them for jobs that don't exist, using technologies that haven't yet been invented, and to solve problems that we don't even know exist yet. So it's a pretty daunting thing. So what do you do? Maybe that's why we send our kids to a liberal arts school or something. That's what we used to do. We'd say, get a broad base of knowledge, and then based on that, you can actually be adaptable to the new challenges that are coming. I think this is what we try to do. We're trying to create Renaissance people in conservation, not necessarily all scientists. We do plenty of graduate students and postdocs and things like that. But we have to concentrate on this sweet spot of the 19, 20-year-olds, the ones who want to change the world, who, when you ask them what they want to do, they'll tell you, I want to change the world. I want to have an impact. I want my life to have meaning. And that's the same thing that everybody wants, because it's a fundamental thing that human beings want, whether you're an artist or a scientist or a businessman. And that's what we're trying to instill in people, is what is the tools that you need to understand what the problems are, so that you can help to solve them as they come up, not knowing what they will be. And so we have this thing called the Smithsonian Mason Semester, and so students come and they live in residence. I often joke it's like a study abroad program in Front Royal, which is kind of like a developing country, but in a good way. So they come there for 15 weeks and they get 16 units of credit. We've piloted this thing 4 times, and I've watched these kids come up to a stage and they will literally, many of them will weep. And the instructors do the same thing. Because there aren't that many times in your life when you actually think you've made a difference. And it's really, really cool when you can see that you're changing people's lives. And so that's what we're doing. So with this partnership, we're taking our old remount station, because it was a cavalry remount history of our site was in World War I. It was a cavalry station. Now it's a conservation station. And we're building a $30 million campus there that's going to house 120 undergrads and professionals and practitioners from all around the world who will come there in the community of conservation and hopefully inspire each other to do great things. It's the breaking ground in May. It'll be completed in the fall of 2012. And we're already doing things. We've trained about 4,500 people over our career of being there for 35 years, but we want to take that number and quadruple it in the next 10 years. So I'm going to end with this kind of a thing, sort of the hopeful thing. I hope it's hopeful, because but it's good. Information is power, and knowing what the problem is important before you can figure out what the solution is. And this is you probably, maybe many of you've probably seen this, but this is a composite satellite imagery of the Earth at night, and you can see where all the people are and all the lights, and you can see here the trends in the population boom. And people say we're in the midst of a 6th extinction and all of that kind of thing. And this is a famous cartoon. We've met the enemy and he is us. And Mahatma Gandhi talked about how we might be judged by the way we treat animals. So, what I would say is the future is it's hopeful, because there are people who care and who understand that they can make a difference, that they can make an impact. And I've only touched on the surface of what we do. If you'd like to know more, you can just Google us, SCBI or Smithsonian Conservation Biology Institute. We have a newsletter that comes out. You can sign up for that. And I think with that, I'd be happy to answer questions. Thank you.